Okay, just picture this for a second. You're deep, deep beneath the ocean, surrounded by this crushing, immense pressure and just total darkness. Now, from that exact spot, imagine trying to launch a missile. I mean, a pillar of fire and explosive force. It seems like it should be totally impossible, right? Like it would just violate the laws of physics. But this is a very real and, frankly, an absolutely incredible feat of engineering that happens all the time. And that really is the million-dollar question. How on earth does a submarine launch a missile without blowing itself to pieces? You've got all that water pressure trying to crush the sub. And then you've got the insane power of a rocket engine trying to blast its way out. I mean, common sense says that firing a rocket inside a tiny enclosed tube, underwater, should just rip the submarine apart. So how do they get around that? Well, the answer isn't what you'd probably think. It's not about just building a super strong sub that can withstand a massive internal explosion. No, the solution is way more clever, way more elegant than that. It's this perfectly timed sequence of events, kind of like a dance between physics and engineering, all designed to outsmart the very dangers we're talking about. So it all begins with getting the launch tube ready. And this first step is absolutely critical, and it happens long before any fire or force is even a part of the equation. It's all about dealing with that number one threat from the outside, the crushing pressure of the deep sea. And here it is. This super simple action is the key to the whole thing. Before that big outer hatch can swing open, the entire launch tube is flooded with seawater. Why? It's simple, but it's brilliant. It equalizes the pressure. You make the pressure inside the tube the exact same as the pressure outside. That way, when the hatch finally opens, there's no sudden violent change. The ocean doesn't come flooding in and crush the submarine. It's a total game changer. All right, so the door to the ocean is open, the pressure is all balanced out, but the missile is still just sitting there. You can't just light the rocket engine inside the sub, right? That would be a complete disaster. So how do you get this huge missile out of the tube and all the way up to the surface? The answer, believe it or not, is one of the oldest forms of power we know: steam. See, here's the trick. The missile doesn't push itself out. Instead, a completely separate system deep inside the sub, a steam generator, kicks into high gear. It creates a massive amount of high-pressure steam really, really fast. You can think of it like a controlled explosion of pure energy. And that energy is what's going to be used to literally throw the missile out, keeping the violent rocket part of the launch far, far away from the submarine itself. So, we've got the pressure equalized, and we've got this powerful ejection force just waiting to be unleashed. Now we get to the finale, the most dramatic part of the whole sequence. This is the moment where timing, physics, and pure mechanics have to work in perfect harmony to pull off the launch. And here's how it all plays out. First, that high-pressure steam we talked about is shot through pipes, and it slams into a massive piston. That piston then shoves the missile upwards with incredible force. We're talking enough power to launch it straight up through all that water. It gets enough momentum to breach the surface, breaking into the open air. And only then, only when it is completely clear of the water and the sub, does that final critical step happen. The rocket motor ignites. And this is the absolute genius of the entire design. The missile's own incredibly powerful rocket engine only lights up once its sensors know it's in the open air. The fiery, loud, and unbelievably violent part of the launch happens dozens of feet away from the sub, safely on the ocean's surface. The submarine? It never feels that rocket ignition at all. All it feels is a quiet, powerful push from the steam. So let's just quickly run through the genius of this system one more time. 1. Flooding the tube completely solves the pressure problem. 2. Using steam for the initial push means the super dangerous rocket engine never fires anywhere near the sub. And 3. Waiting to ignite the rocket until it's in the air isolates the submarine from the whole violent event. It's a perfect 3-part solution to what seems like an impossible problem. It really makes you think, doesn't it? This is just one piece of incredible ingenuity that's happening silently, deep under the ocean. And it kind of leaves you with this cool question to wonder about. What other impossible engineering marvels are hidden from view, solving incredible challenges right underneath the waves?